Moving on to Physical Science, Module 11, we'll be learning about the 4 fundamental forces of creation. Our vocabulary for this unit, we have gravitational force, electromagnetic force, weak force, strong force, electroweak force, and the universal law of gravitation. Let's begin with gravitational force. Physicists believe that there are only 4 fundamental forces in creation. Those forces are gravitational force, electromagnetic force, the weak force, and the strong force, and we'll be learning about all 4. We'll begin with gravitational force because that's the easiest force for us to understand. It actually has a force that is visible to us in that we can see how it reacts with different objects. As an example, a dropped ball accelerates towards the Earth because a gravitational force attracts the ball. The Moon orbits the Earth because the Moon and Earth are attracted to one another by their mutual gravitational forces. Any 2 objects that have mass are attracted to one another by the gravitational force. Of the 4 forces, gravitational force is actually the weakest force. And gravitational force is always an attractive force. It does not repel, it only attracts. Now, electromagnetic force, our second force, this is something that we're also familiar with. It exists between particles with electrical charge. It can either attract or repulse depending on the object's charge. A positively charged object and a negatively charged object attract one another. We've done experiments with magnets, and if you remember, positive sides of magnets attract the negative sides. If you put 2 positives together, they repel. But if you put a positive and a negative together, they attract. The weak force. The weak force, even though it's the weak force, is still stronger than gravity. It plays a greater role in the other forces in the decay of objects. It's only effective for short distances, and it acts on the subatomic level. So a positively charged object and a negatively charged object attract one another just in a similar way to electromagnetic force, but this force occurs down at the subatomic level, like in the atom. So the weak force plays a crucial role in powering star and star elements. I want you to now think about nuclear force and nuclear reactions. Let's look at this picture here. They have a breakdown of the atom, and in the center of the atom is the nucleus, and you have protons and electrons in that nucleus. You have positive and negative charges, but you also have these things that are holding all of the protons and electrons together, and we call those quarks, and they also call them gluons, which is quite appropriately named. The weak force is responsible for much of the natural radiation present in the universe. It governs certain radioactive processes in atoms. It's also the hardest of the 4 forces for us to understand. Scientists believe that the electromagnetic force and the weak force are different facets of the same force. Now, this isn't all scientists, but many of them do. And so they'll often combine the 2 forces and they'll call it the electroweak force. Let's move on to the strong force. The strong force is responsible for holding the center of the atom, the nucleus, together. So before, what we were talking about was the protons and the neutrons, and the strong force is what actually works on the attraction inside the nucleus. Only protons repel one another by the electric force. The strong force is the strongest force in creation, which is why they call it the strong force. And it can counteract the electromagnetic force. If you learn about nuclear fission, this is actually part of what nuclear fission is. It's a small range that only applies to the particles found in an atom's nucleus. Newton actually came up with the universal law of gravitation. And there are three different ideas in this nuclear law. The first being that all objects with mass are attracted to one another by gravitational force. The second, the gravitational force between two masses is directly proportional to the mass of each object. And the gravitational force between two masses is inversely proportional to the square of the distance between those two objects. So in the first principle, all objects with mass are attracted to one another by gravitational force. So all matter is attracted to all other matter. Every object you see is attracted to the Earth, and every object attracted to the Earth is also attracted to the Sun. The second principle, the strength of the gravitational force between two objects increases as the mass of either object increases. So if an object were placed with another object of 2 times the first object's mass, the new gravitational attraction measured will be 2 times the previous measured attraction. So twice the mass, twice the attraction. If the gravitational attraction is doubled again, the gravitational attraction will be 4 times as large. So 4 times the object's mass, 4 times the gravitation. The third principle, gravitational force is inversely proportional to the square of the distance between the objects. Inversely proportional means that when the distance is big or large, the force is small. So if the distance is big, the force is small. And inversely, when the distance is small, the force is big. So the closer the two objects are, the stronger their force will be. The attraction is so strong that an increase or decrease of force will be squared. So instead of just saying 2 times something, it'll be 2 squared. Or instead of saying 8 times 2, it'll be 8 squared. And we'll see this in our examples. So there are 2 examples in this part of the module. One is that the gravitational force between 2 objects separated by a distance of 3 centimeters is measured. So the actual force is measured. The objects are then brought closer together so that the distance between them is only 1 centimeter. What is the gravitational attraction now compared to when it was first measured? So the distance went from 3 centimeters to 1 centimeter, so it actually decreased. We need to remember that gravitational force is proportional to the factor the distance changes. And we need to decide what to multiply or divide the first distance by to get the second distance. So we went from 3 to 1. So to get from 3 to 1, we had to divide by 3. So we decreased by a factor of 3. Gravitational force then will be increased when the distance is decreased. So remember, the force will get stronger the closer it gets. This distance was divided by 3, so the new gravitational force will be 3 squared, or 9 times larger than it was previously. A second example, the gravitational force between 2 objects separated by a distance of 5 centimeters is measured. Both objects are then replaced. The first object is replaced with one that has half of its mass. The second object is replaced by one that has 8 times its mass. What is the gravitational attraction now compared to when it was first measured? So when the first object is replaced with one that has half its mass, the gravitational force is cut in half. Because gravitational force is proportional, the gravitational force is cut in half as well. When the second object is replaced with an object that has 8 times more mass, the gravitational force is increased by a factor of 8. Now we're talking about the actual objects and the force between them. We're not talking about the distance as we did in the last example. So the gravitational force was first cut in half, and then that value was multiplied by 8. This leads to a gravitational force that's 4 times larger than the original force. So 1/2 times 8 equals 4. So it'll take a little while for you to get used to when you square and when you don't square. But let's go back to this slide here. The objects were brought closer together in the first example, and the attraction was then squared. But in this case, the second example, the objects were actually cut in their size or their mass. We didn't even talk about distance. We just talked about the force. So you'll need to be careful about when you have distance, when you have force, and when you have mass in these examples. So hopefully this helped, and be sure to ask questions, and I'll talk to you again in Module 11B.